Alright, this is screencast number 3 for Unit 3, Lesson 1, and I am on page 120. How can we describe atoms? Think of all the substances you see and touch every day. Are all of these substances the same? No, obviously they're not. The substances that make up this book are quite different from the substances in the air you breathe. If all atoms are composed of the same particles, how can there be so many different types of substances? Well, different combinations of protons, neutrons, and electrons produce atoms with different properties. The number of each kind of particle within an atom determines its unique properties. In turn, these different atoms combine to form the different substances all around us. Okay, the number of protons distinguishes the atom of one element from the atoms of another. For example, every hydrogen atom contains one proton, and every carbon atom has exactly 6 protons in its nucleus. The number of protons in the nucleus of an atom is the atomic number of that atom. Hydrogen has an atomic number of 1 because each of its atoms contain. Carbon has an atomic number of 6 because each of its atoms contain 6 protons. Okay, we can also describe atoms by their mass number. So I'm on page 121. The atoms of a certain element always have the same number of protons, but they may not always have the same number of neutrons. For example, all chlorine atoms have 17 protons, but some chlorine atoms have 18 neutrons, other chlorine atoms have 20 neutrons. These two types of chlorine atoms are called isotopes. Isotopes are atoms of the same element that have different numbers of neutrons. Okay? Some elements have many isotopes and other elements have just a few. The total number of protons and neutrons in an atom's nucleus is its mass number. Different isotopes of chlorine have different mass numbers. For example, what is the mass number of a chlorine atom that contains 18 neutrons? Well, we know that chlorine has 17 protons because its atomic number is 17. And we were just told that this particular atom has 18 neutrons, so we say 17 protons plus 18 neutrons and we get 35. If we were going to talk about the one that had 20 neutrons, then we would say 17 protons plus 20 neutrons and we would get a mass number of 37. Okay, if you look down at number 14, use this model of a helium atom to find its atomic number and its mass number. Remember that the atomic number is the number of protons, and I look at the image and there are 2 protons, so the atomic number is 2. The mass number is the number of protons plus neutrons, so that's 2 plus 2. The mass number is 4. Okay, so I'm going to go back and show you my highlights, and we'll talk a little bit more about this. So now that I've marked up page 120 and 121, let's talk about it a little bit more. Okay, on the first page, page 120, I underlined and highlighted that different combinations of protons, neutrons, and electrons produce atoms with different properties. The number of each kind of particle within an atom determines its unique properties. Then I made a note. The number of protons identifies each element. Okay, the number of protons, I'm now under the red heading, the number of protons distinguishes the atoms of one element from atoms of another. For example, every hydrogen atom contains 1 proton, and every carbon atom has exactly 6 protons in its nucleus. The number of protons in the nucleus of an atom is the atomic number of that atom. Okay, so when I say that there are 6 protons in a carbon atom, I also just told you the atomic number, because the atomic number and the number of protons is the same. And that is what makes carbon atoms different from all of the other atoms. Anything with 6 protons is carbon. Anything with just 1 proton is hydrogen, etc. All right, on number 12, how are 2 atoms of the same element alike? They will always have the same number of protons. They won't necessarily have the same number of electrons or the same number of neutrons, but they will have the same number of protons. All carbon atoms, remember, have 6 protons. All hydrogen atoms have 1 proton. all oxygen atoms have 8 protons, etc. All right, on page 121, by mass number, I put out to the side isotopes, and then I put the word variety. I'll talk about that in just a second. All right, I highlighted that the atoms of a certain element always have the same number of protons. We've just said that. But going down a little bit further, these two types of chlorine atoms are called isotopes. Isotopes are atoms of the same element that have different numbers of neutrons. The total number of protons and neutrons in an atom's nucleus is its mass number. Okay? So if I'm going to talk about chlorine atoms, some chlorine atoms have 17 protons and 18 neutrons, and 17 plus 18 gives you a mass of 35. Other chlorine atoms have 17 protons but 20 neutrons, so 17 plus 20 gives it a mass of 37. So those are two different isotopes of chlorine, two varieties of chlorine. So do you understand why I put variety as a synonym for the word isotope? Okay, still the same element. They're both chlorine, but they're not exactly the same. They have different numbers of neutrons. Okay, and then down at the bottom for number 14, I pointed out that, remember, the atomic number for this particular drawing is 2 because there are 2 protons, and the mass number is 4 because I have 2 protons plus 2 neutrons. All right, there are 2 things that I would like you to add to the end of your lesson. So as in addition to going back and answering all the active reading questions, and doing the lesson review, you also need to jot down these notes. And this is the history of the atomic model, starting with Democritus. And if you follow the black arrows, it takes you through from one discoverer or scientist to the next. So Democritus, then to Dalton, then to Thomson, then to Rutherford, Bohr, Chadwick, and finally to the current theory, which is the electron cloud theory. Please put all of this on the back of lesson 1. Okay? You also have vocabulary for lesson 1, but you're probably going to have to put that on the graph sheet that begins lesson 2. And I will give you the vocabulary words in just a second, so hang on. All right, remember you're probably going to have to either put this on a separate sheet of paper or use the graph paper that starts lesson 2. You need to define matter, atom, electrons, nucleus, protons, neutrons, electron cloud, atomic mass unit, cation, anion, ion, atomic number, isotope, and mass number. Those are all your vocabulary words for Unit 3, Lesson 1.